Alright, so today we're going to be going over the FRQ for 2014 question number 3. So, first off, it's saying the function f is defined on the closed interval of -5 to 4. The graph of f consists of 3 line segments and is shown in the figure above, which is the graph off to the right. Let g be the function defined by g of x equals the integral from x to -3 f of t delta t. So the first thing it does is ask us to find g of 3. So what this is asking us to do is find the area under f from 3 to -3. So from 3 over here to -3 right there. So what we want to do here is we can break this into triangles to find the area since the graph is linear. A good way to do this would be to break it into 3 different triangles, right? One for each of the separate triangles. We have this one right here on the left side of the y-axis, the one on the right side of the y-axis, and the one below the x-axis. So, like we say, we have 3 triangles, and from -3 to 0, 0 to 2, and 2 to 3. And then using just the area formula for a triangle, 1/2 base times height, we can take the summation of those and we end up getting 6 for the left triangle, 4 for the middle triangle, and -1 for the right triangle. And when we add those together, we end up with 9. So the next part of the problem asks us on what open intervals contained in -5 to 4 is the graph of g both increasing and concave down? Give a reason for your answer. So what we're looking for is, since g is the integral of f, that means that f is the derivative of g. And that also means that f prime of x is going to be the second derivative of g. So what we're looking for is when it is both increasing and concave down. So that means that f should be positive and f double prime, or f prime, should be negative. So if we look, we have a graph of the second derivative, if you look to draw it out, of g, right? So we see that it's negative on the interval of -5 to -3, and from 0 to 4. We're also looking at this graph at the same time and seeing that since f is positive from -5 to -3, and it's also positive from 0 to 2, that those are the areas that are going to work for us and answer the problem. So g of x is increasing and concave down on the intervals of -5 to -3 and 0 to 2 because f prime of x is negative and f of x is positive on those intervals. And so for the next part of our problem, we're looking at part C, which says the function h is defined by h of x equals g of x divided by 5x. Find h prime of 3. So we're taking the derivative of this function. It's going to be, we're going to have to use a quotient rule to figure that out. So what we see is we have g of x divided by 5x is h of x. So that means h prime of x using quotient rule will be 5x times g prime of x minus 5 times g of x, all divided by 25 times x squared. And so all we have to do is plug in 3 to that, get 5 times 3 times g prime of 3 times 5 times 9. G of x, or g of 3, is equal to 9, which we found in part A, right up here. So we don't have to go ahead and do that. That can save you some time if you're in a bit of a time crunch. And then g prime of 3, when we look at the graph, that's pretty much asking us what f of 3 is. And when we look at f of 3, we see that we get at -2. And so from there, we just, substitute values and put everything together. get negative 75 over 225, which is equal to negative 1/3. Part D says that the function p is defined by p of x equals f of x squared minus x. Find the slope of the tangent line to the graph of p at the point where x equals negative 1. So what we're doing for here, we want to find just the tangent line, so we're looking to find the derivative, so p prime of x. And from what we know here, if we're finding p prime of x, we'll have to find f prime of this. And so if we're taking f prime of x squared minus x, we also have to multiply by the chain rule, so 2x minus 1, which is the derivative of the inside. And then from there, p prime of negative 1 equals f prime of 2 times negative 3 when you just plug in negative 1. And that ends up being negative 2 times negative 3, which ends up equaling 6. So this question is worth 9 points total. For part A, it was just 1 point, which is the answer. For part B, we needed the answer and the explanation as to why it is increasing and concave down. And then for part 3, there were 2 points available for finding h prime of x, and 1 point available for the actual numerical answer. And for part D, we have 2 points available for finding p prime of x, and 1 for getting the correct answer. So as you can see, a big part of it is not just the answer, a lot of it is the work that goes into it. Like you need to recognize for part C that we're using the quotient rule to come up with the correct derivative, and you need to recognize for part D that we're using the chain rule to come up with our answer. So these are very important things to just pay attention to, and knowing that you got the right answer isn't the only thing that matters. Like for part B, we also need a reason and an explanation for why we. So overall, this is not a very challenging problem. There's not too much going on here. The real things that you just need to recognize is that the derivative of g is f. You need to recognize that you're using quotient rule. You need to recognize negative areas. And you need to recognize that you're using chain rule in part D. Really, if you're paying close attention, it shouldn't be too hard to get a lot of points on this problem. There are a few small areas where you could slip up, like where I just said, but I think this one should be pretty easy to do well on and should help you do well on the exam. So thank you for watching.